The first one, it says sine 2 alpha. You can break it down. If you see, that's called double the angle, twice that number. You can break it down to 2 times sine alpha cosine alpha. I can tell you, I use this a lot. You'll see that today too when we start dealing with equations. Sometimes a trig equation has sine alpha on one side and 2 alpha on the other side, and you can't solve it unless the units are matching, alpha and alpha on both sides. So I'll be using that. Cosine 2 alpha equals cosine squared alpha minus sine squared alpha. And I can derive 2 more out of this one. Do you remember from a week ago we said sine squared plus cosine squared equals what? Yep, that's a 1. So if you want, you can make the sine squared equals 1 minus cosine squared, or the cosine squared equals 1 minus sine squared. So watch what happens to this. If I replace the cosine squared here by this one, 1 minus sine squared, I will have 1 minus sine squared alpha minus sine squared alpha. And this will give me what? 1 minus 2 sine squared alpha. So you can either use this or use that one. Or go back to this one again. Instead of replacing the cosine squared, what happens if you replace the sine squared? What is the sine squared equal to? Isn't that 1 minus cosine squared? So that would make it cosine squared minus a minus another one, that's plus. So you will have 2 cosine squared minus the 1. So there's really 3 identities for the cosine 2 alpha. Could be this, could be this, could be that one. So you have to look at the problem and see which one makes the problem easier. For the sine, there's only 1. For the tangent, there's only 1. It's 2 times tangent alpha over 1 minus tangent square alpha. So these are the 3 trig identities for double the angles. I'm going to be using them. This is number 1. This is number 2A, we'll call it. This is 2B. This is 2C. And this is number 3. So for 2, for the cosine, there's 3 of them, A, B, and C. For the sine, there's only 1. And for the tangent, there's only 1. So let's take an example and see how we're going to use them. Do we have a unit circle? I have one somewhere. Just to see if that really is true here, the top one. If I said to you, let's do sine pi over 3. I know the answer to it right there. This is pi over 3. That's the cosine, that's the sine. But I don't want to use this. Somehow when I got my paper, it has smudge all over it. I can't read it. Blocked in. And I'm doing a test and I need it. The dog ate it. So how would I find that? I go, boy, that's a 20-point question. I can't give that up. I can take the sine pi over 3 and write that sine 2 times pi over 6. Is it pi over 3? Yep, isn't it? 2 times pi over 6. By 2, this is 1. By 2, that's 3. So I can use double the angle. That says, oh, that's 2 times sine pi over 6 times cosine pi over 6. Two times, let me look at sine pi over 6. Again, remember, this is chewed out. I don't have it. What's the sine of pi over 6? 1/2. The second one is the sine. The first one is the cosine. The sine is 1/2. And what's the cosine? Isn't it the square root of 3 over 2? Can you simplify that? What's the answer? Sine of pi over 3 is the square root of 3 over 2. Amazing. I found my new sheet. This is sine pi. This is pi over 3. What's the sine? Square root of 3 over 2. So we can actually use that sometimes when something is missing to find the missing value. Let's try another one. About this example. Let me try another one. If cosine alpha is equal to 3 over 5 and alpha in the fourth quadrant, alpha belongs to 3 pi over 2 to where? To 2 pi. That means in the fourth quadrant, right? Between 3 pi over 2 and 2 pi. Remember? This is 0. This is pi over 2. This is pi. This is 3 pi over 2. And when you complete a full circle, what is that? 2 pi. So I'm telling you it's in the fourth quadrant, right here. That's another way of saying it. Between 3 pi over 2 and 2 pi, somewhere here. The question, can you tell me what is sine 2 alpha equal to? And what's cosine 2 alpha? And what's the tangent of 2 alpha while I'm at it? Well, before I answer that, because I know sine 2 alpha, the equation we have is what? 2 times sine of alpha times cosine of alpha. I got a problem. I only know one of them. I don't know what sine of alpha is. I know what cosine of alpha. So I need to find sine of alpha. So let me go and solve for sine of alpha. We are in which quadrant? Fourth. The angle in the fourth quadrant. So here's my angle. Somewhere in the fourth quadrant. Don't worry about the scale. This is alpha, somewhere here. We know the cosine is what side? The adjacent over what? Hypotenuse. Can you find that side?
4.
4. 3, 5, 4. Would be actually a negative 4. Because why? It's below the axis. So that tells me now I know what sine of alpha is. The sine's opposite over what? Hypotenuse, 5. So now if you come back and plug it in, so what do we have? The bottom is what? 25? 3 times 4? 12 and 2? Negative 24 over 25. Can I find the cosine of 2 alpha? We said that's what? You can use any one of them. You want to use the cosine square minus the sine squared. Do we know what the cosine? 3 over 5 squared. Do we know what the sine is? Negative 4 over 5 squared. 9 over 25 minus 16 over 25, and the result is what? Negative, is it 7 over 25? Let's do the tangent. Well, the tangent, I could find the tangent and use the equation too, but I'm going to take the easy way out. Tangent is what? Sine over cosine? What's the sine? Negative 24 over 25. What's the cosine? Negative 7 over 25. You multiply both sides by 25, you end up with negative 24 over negative 7, which is 24 over 7. Positive, right? No. 28, yeah. I know what you're thinking. You're going, wait a minute. I thought all students take calculus. All stores take chicken. Or take cash. All students try chicken. I don't know. I don't know what all stores take cash. Sine, cosine, tangent positive here. Sine's positive, cosine the tangent. How come the tangent all, I'll use this one, stores take cash, right? That tells you who's positive where. All students take calculus. All students try chicken. Whatever you want it to be. I don't know why chicken came to my mind today. Sine is positive. Cosine is positive. Tangent's positive. Only the sine is positive here. Cosine is negative. Tangent is negative. T for tangent. Tangent is positive here. Sine is negative. Cosine is negative. C for what? Cosine is positive here. Sine is negative. Tangent is negative. How come my tangent is positive?
Because it's the
Because you're going to double that angle. And if you double that angle, it's going to put it in this quadrant. Right? It's going to be twice the size of it. So twice the size is going to put it somewhere here. So which quadrant? That's this. That's why the tangent is positive. And notice your sine is what? Negative. And notice your cosine is what? Negative. It's twice that angle. It's not in this quadrant. It's in this quadrant. You say, wait a minute. What about if the angle is negative 15? Twice of that. It's not going to be here. Well, it's not negative 15. We know that because look at the sine. 3 over the cosine 3 over 5. The sine is what? Where's the sign? Negative 4 over 5. So it's a good size angle. It's more than 45 degrees because of this number. So it's more than 45. So it's in this, when you flip it, that's more than 90 degrees and put you in this quadrant.
Bless you.
Oh, beautiful, huh? I feel you like that stuff, Ricardo.
I do.
Yep. Okay. Let's try another double the angle. You might be given a problem like this. Simplify. Two divided by 1 plus cosine 2x. I want to simplify that. Well, I can take cosine 2x, replace it with either cosine squared minus sine squared. But if I do that, well, I could. There we go. I wasn't planning on doing that. I was about to say cosine squared here minus sine squared. Clean it a little bit there. Let's write that 1. Let's put the minus sine squared next to it. I'm just shuffling things around. Any problem with shuffling here? Now wait a minute, I just wrote something on the board, on my notes here. What is 1 minus sine squared equal to? That's cosine squared, right? So I can make that 2 over cosine squared x plus cosine squared x, which is what? 2 over 2 cosine squared x. The 2's will cancel. 1 over cosine squared x. And what's 1 over cosine? 1 over cosine. Secant, so that's secant squared. I can tell you when I wrote this, my first reaction was not to do it this way. I'll do it again. My first reaction was cosine 2x. Instead of using that, let me use 2 cosine squared minus 1. So in place of the cosine, I'm going to use 2 cosine squared x minus 1. And if I do that, what's going to happen to the 1 minus 1? Then they cancel out. So you end up with 2 over what? 2 cosine squared x, which is 1 over cosine squared x. And 1 over cosine, secant squared x. Any way you want to. It works out every time. Okay, let's try another one. Let me try another one. double the angle, simplify. Let's try this one. Simplify. Sine 3x over sine of x plus cosine 3x over cosine x. Now, the only thing I will say, if you want to add or subtract fractions, what do you need? You need a common denominator. So let's see, what's the common denominator? Sine of x, cosine of x. Sine of x, cosine of x. I will have to multiply this by what? Cosine of x. So that would be sine 3x cosine of x. And this one will be what? Cosine 3x sine x. Make it one fraction. I noticed something already. I don't know if you saw it. Sine 3x cosine of x plus cosine 3x sine of x. If you did the homework last week, we did, let me call the 3x alpha. Let me call this beta. Alpha, beta. Go back to section 2. What's sine alpha cosine beta plus cosine alpha sine beta? Work it backward. Isn't that sine alpha plus beta? And what's alpha in this example and what's beta? 3x and x, right? So that's sine, what do we have? 4x? 3x and x is 4x. I'm not done simplifying. I want to simplify that more. Darn it. I was like excited, like if I had a 2 here, that would be nice. But I don't have it. So what can we do? Can I multiply the top and the bottom by 2? You're saying, what's the big deal about having a 2 on the bottom or on the top? So this problem becomes what? 2 sine 4x over what? Sine 2x. I'm not done simplifying. Can do what? To what? Yes, I like that answer. Good job. He said, how about take sine 4x and make it what? 2 times 2x. Double the angle.
Wait, what happened to cosine?
Sine, cosine, the 2 times that is sine 2x.
Oh, yeah.
So here's that 2 in the front. Let me look at this. What is sine double the angle? Sine 2 times this angle. It's 2 times, there we go, sine that angle, cosine that angle. Remember, that's like alpha here. If you treat this as alpha, sine 2 alpha, which is 2 sine of alpha cosine alpha, all divided by what? Sine 2x, and these two cancel each other out, and your answer is 4 cosine 2x. Wow. I'm getting a headache. But that looks beautiful. You can't not like that. Nobody seemed to be excited about it except me. Let me try another one. Simplify. This is probably the hardest part of the course. As I said last time, this chapter, and this section, and the previous section, the next section. This is like, we lock all the windows when we reach this point. We don't want anyone jumping out yet. Sine 2 theta over 1 plus cosine 2 theta. Now I'm trying to simplify that. Well, what's sine 2 theta? Is then 2 sine. Sine, now 1 minus the sine here. Sine 2 theta is what? 2 sine of theta cosine theta. Here's the 1. What's cosine 2 theta? Well, we have 3 options for cosine 2 theta. But if I use 2 cosine squared minus 1, what will happen to that 1? Will disappear, right? That might be easier to simplify. So replace that with 2 cosine squared theta minus 1. And what do we see with the minus 1 plus 1? They cancel. What about the 2's? Cancel. I can cancel more, but let me clean it for now. It looks like sine theta cosine theta over what? Cosine squared theta. Can we cancel one of the cosines? You got 2 on the bottom, 1 on the top. That leaves me with what? Sine theta over cosine theta. And what is that equal to? Tangent theta. Okay, let's try another one. Now you might be wondering why this one in this section, because it's not double the angle. And I'm like you, I'm wondering why this one's here. The only reason I can think is I don't know what the answer to it is either. The only reason I think it's in this section, maybe the answer we're going to come up with is going to be sine 2 theta or cosine 2 theta. Something with double the angle. Or tangent 2 theta. But your guess is as good as mine. Because it looks like there's no 2x, just xx. And you go, well, we're doing double angles. Why is this one here? So that's the only reason, the only justification I can give you is maybe the answer we're going to come up with is going to have 2x in it. That's why it's in this section. So, remember what I said when you have sine, cosine, secant, tangent, all the stuff, I like to change them to sine, cosine. So that would be what? 1 minus tangent is what? Isn't that sine squared x over what? Cosine squared x over secant, which is what? 1 over cosine squared x. I can see it now already. If you multiply the top and the bottom, because I have all these fractions, if you multiply the top of this fraction by cosine squared x, and you multiply the bottom by cosine squared x to cancel the little fractions inside, what are you going to have? What's cosine squared times 1? When you multiply these, that'll be what? Sine squared x over what? Over 1. And what is cosine square minus sine square? Look on the board, number 16. Cosine 2x. So my thinking was correct there, because I looked at like, why is it here? And I really couldn't tell you why is it here. I just had a feeling the fact it's here in this homework assignment, the answer must be double the angle. Otherwise it won't be here. It will be in the previous section. One more. And when I look at these, honestly, I have no idea where I'm going to start. So the first thing that hits me, I start playing with it. Sometimes it doesn't take me there. So I got to look for other techniques. So if you think I know the answer to them coming here, you know I don't even have a book. I have to go grab a book and go through it and see what happens. Simplify this one too. All I know right now, when I'm adding and subtracting fraction, what do I need? Common denominator. Let me start with that, because this is 2 over 1. So all I know, I'm going to be adding fractions. I better make sure I have the same denominator. So this becomes what? 2 sine squared, right? Plus cosine 2 theta. Now start to fall into place. I see cosine 2 theta. I see sine squared theta. They don't match. I got to make sure these are the same type. If this is theta, I want that to be theta. If this is 2 theta, I want that to be 2 theta. So I can change the 2 theta to theta. There's 3 options on the board. So I have the 2 sine squared. And I got to decide which one of them might be the best move here. Well, let's look on the board. Which one is the best move? When I look at these here, notice that 2 sine squared. Well, if I use that substitution, what's going to happen to 2 sine squared? In place of cosine 2 theta, I'll use this one. What will happen to the sine squared on both sides? 1 minus 2 sine squared. And what do you notice about the sine squared now? Bless you. We have what? 1 over sine squared theta. And what is 1 over sine squared? Cosecant. And that's it.